Hello, we're going to look at dividing functions today. What I need you to understand about that is that when we're dividing functions, we're actually creating rational functions that look like this. We're asked for the domain in most of these problems, so I need you to remember that the domain is all possible x values. And when we are looking for the domain, what we're looking for is all possible x values except for the excluded value. Now, the excluded value in an equation is any number that makes the denominator equal to 0. So what we're going to be doing is setting our denominators equal to 0 and trying to find what x cannot be, because whatever x is means the function is undefined at that point. So remember that undefined just means that it's a vertical line, meaning we're trying to divide by 0, which is absolutely not allowed in mathematics. So what I've done here is I've written the first problem. We've got what is the domain of f of x divided by g of x. And f of x is 2x, and g of x is negative 5 plus 3. So all we need to do is put negative 5x plus 3 equal to 0 and solve. So as you can see here, I subtracted 3 from both sides. I was left with negative 5x equals negative 3. I divided by negative 5 on both sides, and that left me with x is equal to 3/5. Well, that is the excluded value, so we know x cannot be 3/5, which means our domain can be all real numbers, every x value, except for 3/5. All right, let's look at number 2. So we're saying, what is the domain of f of x divided by g of x? F of x is going to be 5x divided by 2x plus 4. All right, so we've got 2x plus 4. Set that equal to 0. Because again, we're trying to find where is the function undefined. Well, I've got 2x equals negative 4 divided by 2 on both sides. X is equal to negative 2, meaning the function is undefined at that point. So x can't be negative 2, but it can be everything else. So our answer would be all real numbers except negative 2. Number 3, we've got, again, what is the domain of f of x divided by g of x? And we've got 2x plus 6 divided by negative 3x squared. We do the same thing. Put negative 3x squared equal to 0. Now you're probably already thinking, wait a minute, I don't really have to do that because I know that 0 multiplied by any number is just 0. We're just going to prove it mathematically. So I'm going to divide by negative 3 on both sides of the equation. And that leaves me with x squared equals negative 3. I'm sorry, 0. 0 divided by negative 3 is just 0, I'm always thinking. So I'm going to take the square root of both sides. Square root cancels out a square. They're inverses of each other. So that leaves me with x is equal to the square root of 0, which is just 0. So our excluded value would be 0. So our domain is all real numbers except 0. Number 4, we've got, again, f of x divided by g of x. Our f of x is negative 3x. Our g of x is 3x plus 1. And you're probably already doing this. Ms. Clark, put 3x plus 1 equal to 0. Solve for x by subtracting 1 from both sides of the equation. So I've got 3x equals negative 1. I'm going to divide by 3 on both sides of the equation, and that gives me x is equal to 1/3. But again, negative 1/3. Be careful, because see, they were trying to get me, but I'm not getting got this morning. All right, So x is equal to negative 1/3, which means that is the excluded value. All the x values can be anything but negative 1/3. So our answer would be the domain is equal to all numbers, all real numbers, except negative 1/3. Number 5. Again, we've got f of g of x. And here we've got f of x is 2x squared minus 2 divided by x squared plus 8x. Now, here, it looks a little bit different from what we had before. So the first step in this is to take out the GCF, the greatest common factor, because if you notice, both terms have something in common, and that something in common is x. So we're going to take the x out, and we're left with x plus 8. Now this time we set both of them equal to 0. So x equals 0, x plus 8 equals 0. Well, this one's already solved. This one is not. So we're going to subtract 8 from both sides of the equation, and we're left with x is equal to negative 8. So x cannot be 0 in the domain, and x cannot be negative 8. Those are our excluded values. The domain, therefore, would be all real numbers except negative 8 and 0. We're going to do it again. So we have number 6. And this time we've got p of x divided by c of x. Guys, it doesn't matter what the letters are called. The process is exactly the same. So we've got negative 2x squared plus 2 divided by x squared minus 3x. We've got a GCF, so we're going to take out the x from both of these terms. That leaves us with x minus 3. Set both equal to 0. We're going to add 3 to both sides here of the equation. So x cannot be 0 and x cannot be 3. Move that over there so you can see. So our domain is all real numbers except 0 and 3. Alright, our next problem is 3x squared minus 6x, which is our f of x, divided by our g of x, which is 2x plus 1. So we're back to 2x plus 1 equals 0. We're going to solve. So we're going to subtract 1 from both sides of the equation. We have 2x is equal to negative 1. We divide by 2 on both sides of the equation. Therefore, x is equal to negative 1/2. So we know that negative 1/2 is our excluded value. So our domain for this function would be all real numbers except negative 1/2. Number 8. We've got a of x divided by h of x, and we're looking again for the domain of that. And that would be x plus 2 divided by x squared minus 2x. We've got a GCF here. So we're going to end up with x multiplied by x minus 2. Set both equal to 0. And solve for x. Here we're already solved for x. Here we're not. So we're going to add 2 to both sides of the equation. Therefore, the domain of the function can include all real numbers except 0 and except 2. Number 9. Move that up a little bit. We've got, again, f of x divided by g of x. And we have 2x squared divided by negative x plus 2. Now, same thing. Our answer is going to look a little bit different though. Here we're expected to write our answer as a polynomial or rational function in simplest form, and we're expected to give the domain as well. So here I've already written it. Now we're just going to take care of the domain portion. So I've got negative x plus 2, set that equal to 0. Now you could just move the 2 by subtracting it from both sides, or to make it easy on yourself, instead of doing that and adding an additional step where you have to divide by negative 1 on both sides of the equation, you could just move the x. So let's make the x positive. And we end up with x is equal to 2, or cannot be equal to 2. As you can see here, I've written the problem 2x squared divided by negative x plus 2, which is here, and I'm saying that domain cannot be 2, but it can be all real numbers except. Alright, here is our next one. Alright, in this problem we've got p of x divided by d of x, and it's negative 3x squared plus 3 divided by negative x squared. Now remember, we're told to write this polynomial as a polynomial or rational function in simplest form. This is not in simplest form because we have a GCF on the top. So what we're going to do first is we're going to take out the GCF, which is negative 3. That leaves us with x squared minus 1. And then on the bottom we still have negative x squared. Well, still not simplified yet, because what we know is a negative divided by a negative is a positive. So these negatives will go away. What we also know is that this is the difference of squares, because if I do x times x, I get x squared. And if I do 1 times 1, I get 1. And anytime we have a difference of squares, that means that we had two binomials. One was added, one was subtracted. Let me show you what it means. So I would go negative 3, x plus 1, and x minus 1. Difference of squares is that easy. Take the square root of the first term, the square root of the second term, put a plus and a minus between both of them. So our simplified form would actually be 3, x plus 1, x minus 1 over x squared. And then we have to do the final part. X squared set equal to 0. Well, we already really know the answer to this, but let's go ahead and prove it. We're going to take the square root of both sides. So the square root cancels out the square. With that, x is equal to 0, or the domain cannot be 0. Alright, here is our next question. I'm going to go ahead and pause this and write it down. Alright, again we have a GCF here in our f of x portion. It's 3x squared minus 3. So we're going to take out the 3. That leaves us with x squared minus 1 over negative x. Well, here we go with the difference of squares again. So this would be 3, x plus 1, x minus 1 over negative x. Well, there's no more simplification that can be done for that. So now we need to go ahead and find our domain. Negative x is equal to 0. Well, we know in front of the negative x here, the coefficient is 1. So we're going to divide both sides by negative 1. Therefore, x is equal to 0, or our domain can include everything except 0. Alright, and here is our next question. So we'll call this number 12. And we've got f of g of x. And for f of x is negative 4x over 5x plus 2. Well, we can't do any simplification to that. So now let's find the domain. It's 5x plus 2 is equal to 0. We're going to solve by 4x. Let's subtract 2 from both sides of the equation. We've got 5x equals negative 2. Divide by 5 on both sides of the equation. Therefore, x is equal to negative 2/5, meaning that negative 2/5 is our excluded value. The domain would be all real numbers except negative 2/5. Alright, so we've got negative 4x over 5x plus 2. Our excluded value is negative 2/5. Alright, so we've made it to our 80. You go ahead and see if you can make it 100.